All right, so looking at this here, okay, we got the misleading graphs and statistics, and what we're going to look at here is recognize the misleading graphs and recognize misleading statistics. Now, this is a part of math that you see a lot, okay, in the real world, especially like with what's gone on the past few months with the election. Okay, that's going on. Just looking at misleading graphs with the election. Also, too, a lot of companies, when they advertise products, they want you to think theirs is better than everybody else's. Or on the flip side, they might want you to think that their competitor is no good. Even on the other hand, when you guys get older and you get jobs where you've got to do presentations, you yourself might present a misleading graph or type of misleading statistic. And that's what we have here. Okay, looking at random sample. Okay, that's another term we'll cover today. Random sample, what that means, all that is just anybody in a group has equal chance of being surveyed. And we're going to go more in depth with that too as we go. And then of course, graphs, they can be used to influence what people believe. That's what I'm saying, the election, there was a lot of that going on with graphs that are wanting you to think that, that a certain candidate may be significantly better than another. The way data is displayed, okay, that can influence how it's interpreted as well. So you might one day be doing a graph like this of your own. So we look at this right here, a misleading bar graph, okay? Looking at this graph here, it shows customer satisfaction with different brands. Here you've got brand A, B, C, and D, and they're telling you here the percentage of customer satisfaction. So we want to look and see, why would this graph be misleading? Well, let's look at the one that's the highest first of all. That's B, brand B. Now this graph wants you to think brand B is a lot better than the others. But if we look over here on the y-axis, satisfaction percentage, about 85%. Compare that to A, about 79%. Is that really that big a difference, you think? Not really, no, yeah, not really. But they try to make it look like brand B is way better than brand A. And really it's a little bit better maybe, but not a ton better. Okay? So that's what they're talking about with a misleading bar graph. They want you to think that brand B is just this awesome brand, much better than A, C, or D. And the reality is, it's a little bit better. And then of course, another way to look at it as well, notice the scale on the vertical or y-axis where it starts. Okay, it starts at 76. And because of where it starts, you see that right there, okay, Ellen? That exaggerates everything. It goes from 0 to 76, and then it just goes up 2, 2, 2, and 2. I mean, that really exaggerates things a lot if you look at it that way. See what it's doing, Casper? Yeah. All right, so looking at this here, all right, it says the graph shows customer satisfaction with different brands. Okay, we're looking at the same graph here. What might somebody believe looking at this graph? What might someone believe looking at this thing? What do you think, Nevin?
That B's better.
That B's better? Like a little bit better or a ton better?
A ton better just because how the graph is.
Yeah, that's a good answer.
Because they would look at that instead of looking at the numbers.
Yep. They'd be looking at the picture and not the numbers. They'd be looking at the little yellow color here. Notice this column's way bigger than the other three. What about you, Kay Ellen? What do you think? What's something else that you might see here? That brand B is a lot better than the others. What's something else we might notice? Okay, well, let's look at this. What would it say about brand A, you think?
The worst product.
Okay, yeah, that it's worst, okay? And yeah, according to this graph, it looks like it would be the worst. But is it like a little bit worse or is it a lot worse?
I mean, the D is better than A, so
Yeah,
out of all of them, it would be the worst.
it would be the worst, that's right, but would it be a lot worse than the others?
Mm-hmm.
Exactly, because this is at like 79, this is at 81. I mean, 81, that's not a lot better than 79, and even this, 83, that's not a lot better than 79 either. Okay, so yeah, those would be two good answers, that brand B is a lot better than the others, and brand A is considerably worse than the others. Now, of course, the answer they put is brand B, and that's kind of in line with what Nevin says, but what Kay Ellen says about brand A, that's also true. Okay, that would also be a good answer. Other than that, I'd say those are probably the only two answers that you could really use with this question. What about this one here? Okay, let's think about this one for a second. It says here, who might want to use the graph at the right? Take a minute to think on that. We'll do it orally. You don't have to like write that down. But just take a minute to look at that and think. The effect of fertilizer. Who might want to use this graph? Think, like a company would want to use it, or a person might want to use it.
A co-op or a farmer.
Okay? Because you've got fertilizer A, fertilizer B, fertilizer C, fertilizer D. Who might want to use that?
Farmers.
Okay? All right. Farmer might want to use it. What's another answer we could look at? Somebody that maybe works for who?
Like a gardener.
Okay? Yeah? But think, somebody who might work for A, B, C, or D? Yeah. Why D?
Because it makes their plants look significantly bigger, but it's only like
Yeah.
about
It's
it's only 4 things bigger.
Yeah, exactly. If you look at this, like you say, it's really not even 4 things. It's really less than 4 grams better than B. But if you look at the picture, I mean, this looks like a beanstalk, and that looks like a tree that's only been in the ground just a very short time. And the reality is, it's only just a little bit bigger than that. Does that make sense? Yeah. So somebody, maybe if you worked for the company that's promoting fertilizer D, you'd probably want to use this, wouldn't you think? To make yours look a lot better than the others. And people who look at these graphs, the first thing they're going to notice, and that's we've seen that here, the first thing we notice is how tall the tree is. That's a pretty big tree compared to the others in the picture, but the reality is these numbers here. Okay, so that's that'd be a good way to do it. Company D, or anybody trying to promote Company D, that would be the right answer. All right, so here we're looking now at a misleading line graph. Okay, this is still it's a graph just like the other one. The other one was a bar graph. This is a line graph. Here it says the graph shows the amount of rainfall by year in a particular metropolitan area, like a city. And they want us to explain why this graph is misleading. Okay, so what they're looking at here, down below here on the x-axis, you've got the year 95, 97, 99, 01, 03. Now, one thing they should probably point out is in between here, like this line here, that should be 96, 98, 2000, and 2002, and then of course 2004. at the end there. So what they want us to do is explain why this graph is misleading, okay? Well, let's look. The amount of rainfall, these are the inches. One thing we can look at here is what do we notice about this y-axis?
It starts at 50.
Yeah.
Okay, well, it starts at 0,
Yeah.
goes to 10, and then from 10 it goes to 20. All right, so far it's about right. And then from 20 it goes to 30, and then from 30 to 40. So it's going by 10s up until we get here. And then it starts going by 5s, 45 and 50. You see that? All right, you see, yeah. So it's going 40 to 45. That tells you right there that you know, it's not consistent with what's down here. Okay, so that's one thing we could say that makes this misleading. And then another thing too, look at the numbers here, like 95, it's at, well, looks like it's right at maybe 52 or 53 inches. And then, yeah, up here looks like it might have gone up to about 53 or 54. And then here, that looks about right, 51. So far here, everything looks okay. But look what happens here. Like it goes down to about 41. So it only goes down by about 10 inches, which, you know, 10 would be from like here to here, here to here. But here, because of that 45 being right there, that causes this to look a bit more distorted than it should be.
So it's not even that much more or less.
Yeah, exactly. It's not even that much. It's making it look like it's a lot more than 10 because of these intervals here. This 45, it's what throws everything off. And then after that, it doesn't look so bad. But that's the big thing to notice. So yeah, the intervals on the axis here, as we talked about, at 45, it throws everything off because the intervals aren't equal. It starts out with 10s and then it goes to 5, and that's what's causing it. Here, okay, it says the graph shows the amount of rainfall by year in a particular metropolitan area. Okay. So that's what we have here. What might people be influenced to believe by this graph? Okay. So if we look at this graph, what are some things that people might be led to believe by looking at this?
That the rainfall decreased.
The rainfall decreased. Okay. Well, did it decrease?
Yeah.
but
Yeah.
not a lot.
Not by much.
Not by much, right? Yeah. It makes it look like it decreased by a ton when really, you know, it didn't decrease by much at all. What's it doing between 97 and 04?
Yeah,
It's like that.
Is it going down or is it,
It's in between what?
you say it's fluctuating?
Lisa, between what?
Oh, between, like from 1998 to 2004.
It goes like up and down.
Yeah, it's going up and it's going down.
Down, up, down.
Yeah, so it would be kind of fluctuating a bit. But again, somebody might believe that the amount of rainfall may have decreased the most between 1997 and 1998. But looking at from 1998 to 1999, notice the change was about the same. And again, it's this 45 that just throws everything off. Does that make sense? Because from here, this is at about maybe 42, and then from here it goes down to about maybe 31. So this decrease is the same as that decrease, even though it may not look that way, and it's that 45 that's throwing everything off. Okay, so looking at this one here, this is a different type of graph. It's asking who might want to use this graph at the right. Okay, so what this graph at the right is explaining is average gas prices in September of each year. So who might want to use this type of graph here? Who's someone that might want to use it?
People who drive a lot,
People who drive a lot?
like taxi,
Okay, very good.
uh,
Taxis, yes.
what else?
Who are some others that,
Like 18-wheelers when they
Yeah.
drive long distance,
sure,
bus drivers.
okay? Those are very good answers. Okay, because what they're talking about here is the gas prices that are, looks like it's going up each year. But somebody that's definitely involved in transportation, that's somebody who would want to use that for sure. But yeah, those are great answers. 18-wheelers, taxi drivers. Those are definitely good answers there. Okay, and then it even says what Nevin was saying, possible answer. Okay, there's more than one right answer to that. Taxi drivers, and it says the drivers could justify charging higher rates by using this graph, which seems to show that gas prices have increased dramatically, and really have they increased dramatically if you look at that closely.
Well, from 108 gallon to 124, that's like kind of like a little leap.
Yeah, it's somewhat of a leap.
Like, but then it didn't really double until 2001.
Yeah.
Okay? So what you're saying is it increased by about the same amount from, it went up about 16 cents here. And then here it goes up about 18 cents.
Yeah.
Okay? So would you say it actually made more of an increase from here to here?
I mean, yeah.
Yeah. Yeah.
I mean, the biggest increase would be from 1.26 to 1.43, right?
Yeah. That would be an increase of 15, but from 124 to 143, that would be an increase of 19. But look over here, 108 to 124.
That's a 13.
Exactly. It's not as much. If you look at the numbers from here to here, it's not as much as it was from here to here. In fact, from 1993 to 1997, it increased about the same as it did from 99 to 01. Yet it doesn't look like it's made that much of a jump. Do you notice anything with the y-axis there?
It goes up by 2s and then it starts going up by 20s.
Yep, that's a good point. Now, from here to here, it goes up 10, but what you're saying is also true. It goes up by 12, but then now it's going up by 2s, like you said, 12, 14, 16, 18, 20. Then it goes up by 20, and then it goes up by another 20. Yeah, so that's a good point there. So yeah, that's how you would do it. All right, that's what they're talking about. All right, so looking at this, this next part that we'll look at circle graphs. And what that does, it compares each category of a data set to the whole. And when a category is not represented in the graph, it may appear that another category represents a greater percentage of the total than it should. That's a lot easier once you see examples, but they're just explaining exactly what a circle graph is. So if we look at this here, we've got a circle graph that shows the allocations of county budget for 2005, and we want to look and see why this is misleading. And it's a lot like the other graphs we've looked at. I think it'd be easier to notice on here than it would on a line graph. Maybe not necessarily a bar graph, but on here it's definitely easier to notice than a line graph. So what can we say about this? What are some things we might notice?
It
Well,
only adds up to 60%.
that's a big one. Okay, that's definitely a big reason. Anytime you have a circle graph, it's supposed to add up to 100%, but like Casper said, this only adds up to 60. Because 25 and 20, that's 45, plus 10, that's 55, plus 5, that's 60. Where's the other 40%? This is only half of it. And what's it also trying to show us in addition to that? Well, road maintenance, we would think, looking at this graph, that half the budget is for road maintenance, but the reality is it's only 25%. But they're trying to make it sound like road maintenance is half the budget for the county in 2005. Does that make sense there? You see why it's that way, Kay Ellen? Because this is supposed to show only, they're trying to make you think it's half when it's actually a fourth. But that's how that would work. So we want to look and see, okay, the sections of the graph, they don't add up to 100% like Casper said. So the expenditures are not accurately represented. That, and also keep in mind that 25% looks a lot bigger than it really is. So looking at this, all right, so they're asking us, what are some things that people might be influenced to believe by looking at this? What's something we might be influenced to believe by looking at that? What do you think, Kay Ellen? What could someone think by looking at that?
Our road maintenance takes up less budget.
Yeah, that it takes up a lot more than it does, sure. Anything else we might notice? Is there anything else we might notice besides that?
Only goes up to 60.
Of course, yeah, that's a big thing. At first glance, we might not notice that, but if we look at it closely, yes, we would notice. But really, I think that would be the best answer, which was what Kay Ellen gave. So there it says, someone might believe that road maintenance takes more than 50% of the budget. So that's kind of in line with what Kay Ellen said, that road maintenance is more than it appears. What's up?
25% is more than the 30% that Parks and Rec and then the social services would be.
Okay, that's very good. Okay, that's, yeah, I think you'd be right. Because if we look at this, 20% for social services, Parks and Rec, 10%, that 30% right there, or that is 30%, and you look at here at the 25%, so yeah, even though the numbers say Parks and Recreation along with social services combined is more than road maintenance, a little bit more, yeah, it actually is a little more. That's very good that, yeah, I mean, you're right, it's not even on here, and that's a very good observation, no doubt. All right, so looking at this here, you have student council election. Okay, so of course this is not a national election, just a student council election. Who might be interested in using this graph? Who's someone that might be interested in using that graph?
Smith.
Okay, Smith, or somebody who supports Smith. Why do you think? Say what?
I guess that one.
Yeah. You know, Smith got 20% of the votes, but here it looks like, you know, he got about 60% of the votes. Okay? And here you have the 10 and 15. So what's something we might notice that's wrong with this graph? It doesn't add up anywhere close to 100. It adds up to only, 35. So, you know, we don't, it's not really accurate in the way it explains it. But yeah, somebody who supports Smith would definitely want to use that. And, yeah. Okay. And then looking at this here, statistics, this goes back to what we were talking about earlier with the random sample. Okay, and like I said earlier with the random sample, that means all members of the group being surveyed have an equal chance of being selected. And statistics, they can be misleading because of the way data is collected or by the way it's reported. Usually it's by the way it's collected, because you got to think where surveys may be done. For example, if you want a survey to find out like how many people in Nashville like football, and you decide to do your survey out front of Nissan Stadium after a Titans game, people on their way out of the stadium, well, what do you think most people are going to say?
Yeah.
Yeah, that they like football. Okay. But if you did the same survey over at, say, a botanical garden, for example, do you think you'd have as many people coming out of the botanical garden saying that they like football? Not as many. You might have a few. So that's what they're talking about with misleading statistics. You got to think where they're getting these reports from. You know, if you ask for another example, might be you're trying to find out how many people like skiing. Well, it depends on where you do the survey. If you do the survey at a ski shop or at a ski resort, you're going to get a lot more people saying they like to ski, as opposed to if you went to Florida on the beach, asking people at the beach if they like to ski. You know, does that make sense?
Yeah.
Now, of course, you know, they might like to water ski, but that's what they're talking about by misleading statistics. So we'll look at this here. It says a study of 5 households have found the following numbers of pets per household. Okay, so it's 2, 1, 1, 9, and 2. Okay. And they want us to explain the following statement. They want us to explain why that's misleading. And here's the statement. The average household has 3 pets. Okay, so let's look at this again. The study of 5 households found the following number of pets per household. 2, 1, 1, 9, and 2. So they want us to explain why that's misleading. It says the average household has 3 pets. Well, look at the sample size, 5. So you're going to base the average household in the United States, or even Tennessee, or heck, even Murfreesboro, you're going to base that off 5 people? I mean,
it's honestly kind of true because I have 3 pets.
yeah. Well, yeah, you.
So.
But how many pets
Yeah,
does Nevin have?
Lucy, Cooper, and I have Minxie.
Yeah. So you got 3 pets in your house?
Cooper.
Cooper, that's Shannon's cat, but Chris was supposed to get him.
Well, how many pets do you have, Nevin? You got 2? All right, so we got 3, 2. What about you, Casper? How many pets you got? 3. So 3, 2, 3. Well, guess how many pets I have?
0.
Exactly right, 0. Yeah. So, again, even with us, you know, like our sample size of 5 households, you know, the one we just sampled literally just now, 4, it's too small to achieve accurate results. This sample implies that each household has pets, when many probably do not. I don't.
Yeah, because if you went on like what we just like our survey,
Yep.
like
I'm about to have
1 out of 3 people don't have cats, or like
1 out of 4.
1
Yeah.
out of 4 people don't have cats.
Why don't you have any pets? It's boring.
My wife's allergic to.
Oh.
Yeah.
Oh.
She lives in cats.
Get a hairless cat.
Oh yeah. They love
Yeah.
hair, so like if you have hair, they'll like come rub on it. I think it's weird.
Yeah, I had pets growing up, but you know, she didn't. Yeah.
I couldn't imagine
But
Growing up without pets.
I had dogs and cats growing
I
up,
don't
and
have pets.
that was a lot of fun.
You need to come see your baby.
All right.
You should
All right.
see
So
her.
looking at this here, okay,
No, she's sweet.
what we got here, it says a researcher, it asked 4 people if they have seasonal allergies. 3 people respond yes, and then it explains 75% of all people have seasonal allergies.
that. Oh, that's like what we just did.
Yep. Now the sample size is much too small, but something else I would want to add to that. Okay, these 4 people, I'd like to know where he asked these 4 people. Because if you're asking about seasonal allergies, if you go to the pharmacy at Walgreens and look in the section over by the pharmacy where they sell all the medicines, and you're asking people if they have seasonal allergies, you're going to probably get a lot more people saying yes than if you did, say, if you did the same survey over at the frozen food section at Kroger's, for example. So you see why you might get a different answer depending, like where you do your survey, that makes a big difference. Okay, and then of course the sample size is much too small, because you're saying 75% of all people, you only talk to 4 people. And yeah, 3 out of those 4 say yes, but that's just 3 out of 4 random people. You know, you'd have to probably do a much bigger sample size than that, obviously. Okay. All right, so we'll look at this here. So what's one reason why this might be misleading? What do you think, Kay Ellen? What's a reason why you think this is misleading?
Because the X, it's only a difference between 45 and 47.
Yeah. Okay, only a difference between 45 and 47. Anything else you might notice? That's true.
The cost goes up by $2.50.
Okay, the cost is going up by $2.50. But what do we notice? What else do we notice about the y-axis? It what?
Starts at 40.
Yeah, it jumps to 40 suddenly, and then it just goes 250 the rest of the way. That throws everything off. And what does that lead us to believe about Z, about Portrait Z?
It's the worst, but
The worst?
really it's not even that
It's only $5 worse than.
$5 worse, $5 cheaper. Cheaper's not always, cheaper doesn't necessarily mean worse.
Yeah.
Yeah. But, so this right here, it throws off the whole graph. It makes you think that 4750, it's like, wow, this Studio X is a lot more expensive than Studio Z. Or Studio Z is a lot cheaper than these others. But really, if we look at it closely, that's 41. This one right here is probably around 50. But you would think, looking at this, that it was way, way, way more expensive, and it's not. So yeah, what Kay Ellen says is true. And that Studio Z and Studio X, the difference between those two, that would be one right answer for sure. What about this one here? What do you think, Casper? Why would this be misleading, you think?
Well, I mean, it's really hard to read the X.
Okay. Now what they're talking